All right, let's talk about magnetic fields around solenoids. One of the most useful types of magnet is the electromagnet. Um, it works as long as the current is flowing, and it stops as soon as the current stops. An example of this is the magnet that they use in scrap yards or um, big garbage lots, objects that lift metal objects like cars, because it would really suck if you had a magnet to lift a car and then when you were done lifting the car, it wouldn't let go of the car. Some of you, when you were younger, maybe you took a nail and you wrapped a wire around it, yes, and then used it to pick stuff up. This is an example of an electromagnet. An electromagnet is, if you only use a single straight conductor, they wouldn't be very powerful. So what we do is we use a bunch, and I'm going to draw a picture here. Here is a single loop of current, a loop of a conductor. I've got current flowing in this direction here. I get out my right hand and I grab the wire right here, and I would see that the magnetic field goes in through the middle and it's pointing up on the outside. If I grab it here, I would see it like this, and like this, and like this. Sorry. And like that. And all these lines point in the middle, they're all pointing in or down into this thing. And again, I just used the right hand rule that we learned, that we've already learned. So I have a couple of other diagrams that other people made. Here I've got current flowing and I see the magnetic field. Same thing is happening here. This last one's a good one. It shows all the magnetic field lines. In the middle, all the field lines are pointing in the same direction. They're very concentrated here. So the magnetic field in the middle of this loop is much stronger. Because note the arrows all point in the same direction through the loop. If I take this wire or conductor many times and I form a coil, or solenoid is the technical term for it, the effect can be intensified even more. So what I have here is I have a coil of wire, and that's what this diagram is trying to show. It's this blue part right here is one of these, and I've got current flowing through these, and it's showing what's the effect of having a bunch of these single loops that I drew. Well, inside I'm going to get a really strong current pointing in this direction. Outside I'll get some too, but it's in the inside, it's really, you get an additive effect. Note that around this little wire right here, right at this point, it's pointing down, it's pointing up, it's canceled, down, up. These are going to cancel each other up, down, up, cancel each other up. Same thing here. So really I get a lot of cancellation except right in the middle where it all adds together and the magnetic field gets much, much stronger. So here a large field is produced parallel to the axis of the solenoid. Yeah, I get canceling in other places, but here it all adds up right in the middle. So to help you remember the directions of the current and the magnetic field, I have, thank goodness, I have another right hand rule. It states that if a coil is held with the surprise right hand, the fingers indicate the direction of the current, then the thumb will point in the direction of the magnetic field inside the coil. So what I have here is a diagram of it. This thing is, it's looping, it's coming in, it's looping around and around and around and So I grab this thing in the direction that the current is flowing. My fingers are pointing in the direction of the current. And then my thumb points in the direction of the magnetic field. In this case, it's going to be pointing in that direction. The strength of a magnetic field depends on a few things here. It would depend on the amount of current. It would depend on the number of coils, and also to what's in the middle. So if I had a coil and current starts going through it, I would get a magnetic field. However, if I put a piece of iron, for example, in the middle here, the magnetic field becomes much stronger. So here are three factors that would affect the magnetic field that I would get out of one of these solenoids. And just for the record, this is that little thing that some of you might have done when you were little kids, when you took a nail, wrapped it around with wire, hooked it up to a battery, and then you could pick little things up with it.